In this video, we're going to look at the graphs of sine and cosine. Here, when we're talking about the graphs, we're taking as an input the x value. The angle is going to be the input into our angle sine, right, or into our function sine, into our sine function. So we're plugging in the angle, and then the output is going to be the sine of that angle. Right? So the x values, those are the angles, and then the output is the actual value of sine. Right? And so, as we remember from our unit circle, right, if we were to look at f of 0, sine of 0 is 0. So our y value, when our angle is 0, the value of sine is 0. So it should go through 0, 0. When our angle is pi over 2, then we have the sine of pi over 2. And so that output is 1. So at pi over 2, we should be up here at 1. And the same is true at pi, well, it goes here. At pi, we're back to 0. At 3 pi over 2, we're at negative 1. And we come back to 0. And we go up to 1. And we come back to 0. And we go down to negative 1. And we come up to 0. And that continues when we move backwards as well. So our x-intercepts, the places where we are going to intersect the x-axis, those are going to occur at every single multiple of pi, for n being an element of the integers. Right? And so as we go through, we'll try to work on some notational things. So this mathematical notation means, at least in this context, is an element of. And this strange-looking z, this is the set of integers. And what are integers? Those are whole numbers, positive and negative whole numbers, along with 0. Positive and negative. Our positive and negative counting numbers, along with 0. Zero is a whole number. The Y-intercept, there is only one Y-intercept, that is at 0 itself. So when we hit the y-axis, it's only there at a y value of 0. The domain is all real numbers, so everything from negative infinity to positive infinity. So we might write this as R, the set of real numbers. We might write that as an interval notation as negative infinity to positive infinity. We could also write it in words. So the set of real numbers. The range, so the possible y values that are output. This includes everything from negative 1 to positive 1. Right? So the y values never get larger than 1, and they never get smaller than negative 1. And we hit every single value between negative 1 and positive 1. So that is our range. As we mentioned in the last video, this is an odd function. Sine is an odd function. It's symmetric about the origin. And if we were to plug in pi over 3, this is the sine of pi over 3. Sine of pi over 3 is root 3 over 2. Great. So that's our graph of sine. The graph of cosine looks similar. It's related, very similar, but not the same. So with cosine, what we're looking at is when we plug in cosine of 0, we should be at a value of 1. At pi over 2, we should be at 0. At negative pi, or at pi, we should be at negative 1. 3 pi over 2, we're at 0. And we're back to 1. And this process continues in both directions. The x-intercepts here, where are those? All right, so this is pi over 2. This next one is 3 pi over 2. And then we have 5 pi over 2. And so it looks like it's the odd multiples of pi over 2. And that's exactly what it is. So how do you represent the odd multiples of pi over 2? All right, so you have pi over 2 times an odd number. Right? Well, an odd number is simply an even number, either plus or minus 1, right? So it's either 1 more than an even number or 1 less than an even number. You could represent it in either way. I will typically write it as 1 more than an even number. Right? So this goes over odd numbers. Right? So it's an odd number times pi over 2. Right? So 1 pi over 2, 3 pi over 2, 5 pi over 2. Similarly, you would have negative 1 pi over 2, negative 3 pi over 2, and negative numbers are odd. You can have odd negative numbers as well. So that's our x-intercept. Our y-intercept is at 1 itself. Right? So when we hit the y-axis, that value is 1. The domain here is all real numbers. So everything from negative infinity to infinity. The range, just like sine, goes from negative 1 to positive 1. This is not symmetric about the y-axis. About the x-axis. It is symmetric about the y-axis. So this is an even function. And f of pi over 3. That's cosine of pi over 3. Cosine of pi over 3 is 1/2. Great. So in the next video, we're going to look at the graphs of tangent and secant and cosecant and cotangent. Yeah, so that's what we'll see in the next video. We'll see you there.